Here is today's problem. We have the square root of x over 1 minus x as the first piece. Then we add the square root of 1 minus x over x to it. Together those two square roots must equal 5 over 2. 5 over 2 is the same as 2.5. Our goal is to find every value of x that makes this equation true. Each square root holds a fraction built from x and 1 minus x. Our first move is to give each square root a short name. Let b stand for the square root of x over 1 minus x. Let c stand for the square root of 1 minus x over x. With those names, the whole equation reads b plus c equals 5 over 2. This shorter form is easier to write down at every step, but the square roots themselves are still in the way. A clean way to remove square roots is to square the whole equation. So we square the left side, and we square the right side. Squaring both sides keeps the equation balanced. Whatever we do to one side, we also do to the other. On the right, 5 over 2 times 5 over 2 is 25 over 4. On the left, we are squaring the sum b plus c. Squaring a sum follows a very familiar pattern. We can see this by writing b plus c times b plus c. b times b gives the first square, b squared. b times c and c times b each give one copy of bc. Together those two copies form the middle term, to bc, and c times c gives the last square, c squared. So b plus c squared becomes b squared plus 2bc plus c squared. Our equation is now b squared plus 2bc plus c squared equals 25 over 4. Let us handle the middle piece first, the 2bc part. b times c is a product of two square roots. Both roots give real values only when both fractions are positive. Both fractions are positive exactly when x sits strictly between 0 and 1. For positive fractions, product of roots is the root of the product. So b times c is the square root of one big fraction. That fraction is x over 1 minus x times 1 minus x over x. The x on top cancels with the x on the bottom. The 1 minus x on top cancels with the 1 minus x below. Everything cancels, and the big fraction is simply 1. The square root of 1 is 1, so b times c equals 1. That means the middle piece, to bc, is just 2 times 1. The middle piece is exactly 2, a plain number with no x at all. Our equation becomes b squared plus c squared plus 2 equals 25 over 4. Now we move that 2 over to the right side by subtracting it. 25 over 4 minus 2 is what we need to compute. The number 2 is the same thing as 8 over 4. 25 over 4 minus 8 over 4 leaves 17 over 4. So b squared plus c squared equals 17 over 4. This new equation has no square roots left in it. Now we translate b squared and c squared back into x language. Squaring a square root just returns the fraction inside. So b squared is x over 1 minus x, with no root anymore. And c squared is 1 minus x over x, also with no root. Our equation is x over 1 minus x, plus 1 minus x over x, equals 17 over 4. To add to fractions, we need a common denominator. The natural choice is x times 1 minus x. Both original denominators divide evenly into that product. We scale the first fraction by x on top and bottom. That turns it into x squared over x times 1 minus x. We scale the second fraction by 1 minus x on top and bottom. That turns it into 1 minus x, all squared, over the same denominator. Now the two fractions share one denominator, so the tops can join. The combined top is x squared plus 1 minus x, all squared. Let us expand 1 minus x, all squared, term by term. 1 minus x, all squared, means 1 minus x times 1 minus x. Multiplying out, 1 times 1 gives us the number 1. Then 1 times negative x gives us a negative x term. Negative x times 1 gives another negative x term. And negative x times negative x gives positive x squared. Adding those four pieces gives 1 minus 2x plus x squared. So the combined top is x squared plus 1 minus 2x plus x squared. The 2x squared terms join into 2x squared. So the top simplifies to 2x squared minus 2x plus 1. The bottom is x times 1 minus x, which is x minus x squared. So our equation now reads as one clean fraction. 2x squared minus 2x plus 1 over x minus x squared equals 17 over 4. To clear the fractions, we remove the denominators one at a time. Our denominator is positive, so we multiply both sides by it. That leaves 2x squared minus 2x plus 1 on the left. The right side becomes 17 over 4 times x minus x squared. Next we multiply both sides by 4 to remove the last fraction. The left side becomes 4 times 2x squared minus 2x plus 1. The right side becomes 17 times x minus x squared. Now we distribute the numbers on each side. On the left, 4 times 2x squared is 8x squared. 4 times negative 2x is negative 8x. And finally, 4 times 1 is simply 4. So the left side becomes 8x squared minus 8x plus 4. On the right, 17 times x is 17x. 17 times negative x squared is negative 17x squared. So the right side becomes 17x minus 17x squared. Now we gather every term on the left side of the equation. We add 17x squared to both sides of the equation. 8x squared plus 17x squared is 25x squared. Then we subtract 17x from both sides as well. Negative 8x minus 17x is negative 25x. The plus 4 simply comes along for the ride. We are left with 25x squared minus 25x plus 4 equals 0. All the coefficients in this quadratic are whole numbers. Every term now lives on one side, in decreasing powers of x. This is a standard quadratic equation in x. We will solve it with the quadratic formula. In our equation, the leading coefficient is 25, the middle coefficient is negative 25, and the constant term at the end is positive 4. The quadratic formula builds x from these three numbers. Inside the formula sits a value called the discriminant. It is the number that lives under the square root sign. So we compute the discriminant before anything else. First, we square the middle coefficient of our quadratic. Negative 25 squared means negative 25 times itself. A negative times a negative gives a positive result. 25 times 25 is 625. So the squared middle coefficient is 625. Next, we need 4 times the leading coefficient times the constant. First, 4 times 25 gives us 100. Then 100 times 4 is 400. So the discriminant is 625 minus 400. That subtraction leaves 225. The discriminant is positive, so there will be two values of x. Now we need the square root of 225. 15 times 15 is 225, so the square root of the discriminant is exactly 15. Now we can write down the two candidate values for x. On top, the formula starts with the middle coefficient, sign flipped. Flipping negative 25 gives positive 25. Then we add or subtract the root of the discriminant, 15. The bottom is twice the leading coefficient. Twice 25 is 50, so we divide everything by 50. So x equals 25 plus or minus 15, all over 50. First we take the plus branch of the formula. 25 plus 15 gives us 40 on top. 40 over 50 reduces when we divide both by 10. That gives 4 over 5, so one value is 4/5. Next we take the minus branch of the formula. 25 minus 15 gives us 10 on top. 10 over 50 reduces when we divide both by 10. That gives 1 over 5, so the other value is 1/5. Both values sit strictly between 0 and 1, so both stay. The last step is to test these values in the very first equation. We start the check with the value x equals 4/5. If x is 4/5, then 1 minus x is 1/5. The first fraction is 4/5 divided by 1/5. Dividing by 1/5 is the same as multiplying by 5. So 4/5 times 5 gives us exactly 4. The square root of 4 is 2, so the first term is 2. The second fraction is 1/5 divided by 4/5. Dividing by 4/5 means multiplying by 5 over 4. 1/5 times 5 over 4 is 5 over 20. 5 over 20 reduces to 1 over 4. The square root of 1/4 is 1/2. That is because 1/2 times 1/2 is 1/4. So for this value, the two terms are 2 and 1/2. 2 plus 1/2 is 2.5, which is 5 over 2. So x equals 4/5 satisfies the original equation. Now we check the second value, x equals 1/5. If x is 1/5, then 1 minus x is 4/5. The first fraction is 1/5 divided by 4/5. We already know that division equals 1/4. So the first term is the square root of 1/4, which is 1/2. The second fraction is 4/5 divided by 1/5. That equals 4, and its square root is 2. This time the terms are 1/2 and 2. 1/2 plus 2 is again 5 over 2. So x equals 1/5 also satisfies the original equation. The equation has exactly two real solutions. Those solutions are x equals 1/5 and x equals 4/5. In decimal form, those are 0.2 and 0.8. Each of them turns both square roots into clean numbers. That completes our work on this problem for today. Thank you very much for watching all the way through. If you enjoyed the solution, a like helps the channel a lot. Subscribing means you never miss the next problem. We will see you again in the very next video.